In this video, we are going to calculate the frequency and wavelength of a piece of light with a specific energy. In this case, it's going to be 3.00 times 10 to the negative 18 joules. And so the equation that relates energy to frequency and wavelength is, in the case of frequency, energy is equal to h nu, where nu is frequency, or in the case of wavelength, what we have is E is equal to hc over lambda. And I just noticed that there's a typo right here, and so that nu over hc should be a lambda below it. And so h in this case is Planck's constant, which is 6.626 times 10 to the negative 34 joule seconds. The c in this case is the speed of light, which is approximately 3 times 10 to the 8th meters per second in a vacuum. So if we rearrange the equations, what we get in the case of the frequency, we have nu is equal to E over h. And so if we plug in our values, what we'll have is 3.00 times 10 to the negative 18 joules over 6.626 times 10 to the negative 34 joule seconds. The joules cancel out within our equation, and so what we end up as our final answer is that the frequency of light will be 4.53 times 10 to the 15 1 over seconds, or hertz. To calculate the wavelength of light, we will use the equation lambda is equal to hc over E. And so if we plug in our values for this, what we will have is 6.626 times 10 to the negative 34 joule seconds times 3 times 10 to the 8th meters per second over 3.00 times 10 to the negative 18 joules. We can cancel out the seconds in our equation, and we can also cancel out the joules so that our final answer is 6.63 times 10 to the negative 8th meters, which is the wavelength of light in this case. So to recap, what we worked through in this video is calculating the frequency and wavelength of light when we were given an energy.